Hey, everybody. Welcome to episode 22 of the eCHO eBPF office hours. This week I'll be joined by Justin Garrison. But first I want to get into the news and say hello to everybody. So see how everybody's doing. Hope you're all signing in and checking in. So if you're with us today, just let me know you're in here in the StreamYard or in the comments, and I'll raise you up so we can see you. In the news this week, we have a little bit of news to talk about. Not a ton, but that's not the one I want. There we go. So this week, a lot of folks who are working on eBPF and all of those sorts of things are involved in the Linux Plumbers Conference. And so if you haven't heard of this is a great way to kind of dig into the detail of the way that networking works within the Linux kernel. And we are, and Cilium and Isovalent are actually hosting the track leaders for the eBPF and networking piece of it today. So that'll be really awesome. Hey, Russell, good to see you. We got Justin, of course. He'll be with us here in a second as well. So if you're interested in any of these things, like understanding a little bit more about how eBPF or networking work inside the Linux kernel, or understanding what's being developed, what's coming, what people are working on, that kind of stuff, the Linux Plumbers Conference is actually a really great place to work on that. And it's not just networking. Linux Plumbers Conference is actually quite a lot of tracks, right? The GNU Tools track, Birds of the Feather, a bunch of other different things, including Linux, including micro conferences and keynotes. So definitely check it out if you're interested. They're also all hosted on YouTube. So if you miss it, you can actually watch all the talks that are happening afterwards as well. So lots of great stuff happening there. Recently, Quentin, who has been hosted by us here on the eCHO office hours before, talking about BPF tool and understanding how BPF works in the Linux kernel, kicked off a Twitter thread that received a lot of attention, and he decided to move it into a blog post. And so if you want to read that blog post, it really kind of digs into some of the details about how BPF tool works, some of the features of it, what it's capable of. It provides a lot of really good examples for how to use it. So definitely check that out if you're just getting started and you kind of want to like play with BPF tool from an operations perspective. That'll be a great blog post. And again, these notes are right here in the lower right-hand corner. You can see hackmd.io at echo live. This is episode 22. So if you go to that URL, you'll be able to get to those notes. One of the other exciting pieces of news this week, a very good friend, Valerie Lancy and James Strong, their book is actually getting shipped out now. It's a Network and KATES, or Network and Kubernetes. If you haven't checked this book out, I highly recommend it. Valerie is super, super sharp. I mean, she's been a huge force inside of the Kubernetes community for some time. If you haven't had a chance to meet her, you should definitely maybe make it to KubeCon, or check on the talks that she's done. She's done some amazing work. But this book also, even from the excerpts that I've seen so far, is looking very, very top notch. If you're interested in understanding more about networking and Kubernetes, and even just low level Kubernetes fundamentals, right? Because at the end of the day, Kubernetes is a system for hosting distributed systems. And when we get into distributed systems, we get into networking. And this book basically takes it from that perspective. We have to think about networking as part of all of this, that's the layer at which we should begin. So good stuff. And then Justin just put up a link. He has a session called Web Scale Open Source with Kubernetes. And I will bring Justin on so Justin can talk about that. Hey, Justin.
Hey.
Welcome.
Thanks. Yeah, I'm having fun. I've never spoken at ATO before. Every interaction I've had so far with the conference organizers has been amazing. Just the initial CFP, and even they had office hours, open office hours. If you wanted to submit a CFP, to hey, come schedule time with us and tell us about your idea and let's see how it works, and great feedback. So I'm really excited to do this talk, and I'm spending a lot of time on it because it's my first ATO talk. And if anyone saw my KubeCon talk from last year, I go a little further than slide decks a lot of times. So I'm spending a lot of time in video editing software and making this one hopefully very entertaining, but also trying to do justice for the Kubernetes community, how it's scaled, how the open source project has scaled. It's a lot of work, and some people don't realize that. It's just it's the Kubernetes thing, right? It's an open source project. Of course it gets released on GitHub. But there's a lot of people that do a lot of things, and so I'm trying to highlight some of that stuff.
Carlos is telling us that he is also going to be speaking at ATO, so that'll be super exciting.
Nice.
Yeah, I like that. I like that idea of like, you know, I mean, that's quite the time commitment to like do office hours for those sorts of things, and I think that's an incredible thing. Like if a conference can pull that off, that's an awesome thing. Yeah, that should be super fun. All right, so our agenda for today is. Why didn't they get added? Oh, they could add it. There we go. We're going to play with EKS Anywhere. We're going to get it deployed. We're going to play with it a bit. We're going to also kind of explore and play with like the fact that this is all cluster API based. And I remember you were mentioning that one of the things that excites you about this is that it is actually making use of so many open source technologies, which I think is really awesome. So
yeah,
we'll be. And then I wanted to show Cilium deployed on here, and then I also wanted to show, kind of talk through like what we could do to get a more full-featured Cilium that is available on those clusters, and we'll play with that stuff as well. So to get started here, Carlos says it started as an open conference with a low price, about $100, and a lot of free tickets to students. That's exciting. Yeah. Oops.
I remember my first conference was Southern California Linux Expo, which was very similar, very small conference, a lot of free. Like I made it there because I was a student at the time, and I think my ticket was $20, which was the reason I could afford to go anywhere. And so I love that, like getting the smaller conferences, getting people started, because there's always new people trying to join these communities and trying to learn things, and making that accessible is great. And I honestly, like, I think remote conferences has done a lot for making things accessible to people.
Really,
a lot of things that turned into free conferences, YouTube channels and streams. I'm excited just to see how many people get involved now.
Yeah, that was one of the big things I think we learned in in playing with or in doing remote conferences for KubeCon, was that like it really lowered the barrier of entry, right? Like people are even, if there's one of the kind of bright shining moments of this whole pandemic thing is the effect that it's had on the community from that perspective, right? Is that we've been able to gather at like a few different KubeCons now and really get like, more people involved, more people, I think, feeling like they're connected with what's happening in the community and getting more of that happening, which I thought was tremendous.
Yeah.
It's not hard at all to install install Cilium in kind. In fact, we are going to be kind of doing that today, and I'll show you why I say that in just a minute. So let's get started up here. So on this side, on the references side of things, we have a few different links I wanted to pull up here. So this is the AWS EKS Anywhere docs, and we're going to go through kind of a little bit of the getting started guide and get moving here and play with things. And so what I've done so far is I've created a VM that actually has everything I need on it, which is basically Docker and a bunch of binaries, like the EKS kettle binary, the EKS Anywhere binary. They follow a very similar plugin method to the way that kubekettle works, which I thought was also interesting. But we're just going to work through this process and get this stuff deployed and play with it a bit and kind of explore like how this stuff works in comparison in relation to a lot of the open source technologies that it's built on top of, because it seems that EKS Anywhere is a packaging of Cluster API with some added bits. And so we're going to look at what those added bits are, and we're going to look at like how we can introspect them and see how they work and that kind of stuff. So what I've done to set up this environment is I've already kind of taken care of these steps, which are basically pulling down the Go binary for EKS kettle and EKS kettle Anywhere and putting them into user local bin. And then I kind of want to get started with deploy a local cluster here. Now, the reason I'm going to do a local cluster is because I don't have a vSphere environment in my house, and so I'm going to use a local cluster, which effectively leverages Kind under the covers as a library, because it's actually using some of the tooling that was developed as part of the Cluster API project for local testing, where we use Kind as a library and spin up Kind nodes and give them jobs. And we're going to look at like how that looks from the kind perspective and also from the EKS Anywhere perspective. And then we'll look at how Cilium is deployed and play with things there. So let's work through these steps first. Before I jump into that, I want to show you kind of like what I've got here. So I've got Docker version, got 2010.8 running. It's all configured for me. I don't really have anything running right now. I have EKS Kettle, and I have EKS Kettle Anywhere. These things are already installed. I've installed a few other commands as well, but I haven't gotten too far with other things. And so I wanted to kind of get this thing started up here. So from the website, let's just go ahead and copy and paste some stuff in here and get started and work through this a little bit together. So EKS Kettle Anywhere does a generate command, which basically generates what would be a cluster API configuration with a little bit of changes. And you can tell it what provider to use. And so you can use provider vSphere or provider Docker right now, and they validate that on the EKS Kettle command line piece. So let's take a look at the generated configuration here. And then we'll get it deployed.
And I'm loving watching you just go through. We spent so much time on the docs to make sure that initial, like, I wanted it to be 5 copy and pastable commands. Like that's like literally like it's great because even watching your flow from, we were on the homepage, you click the blue button and like that was like intentional. Like we kind of have been trained to like, hey, this is how a good experience for like, I want to just try something should be. And it should take, in my opinion, it should take you between a half hour and an hour to do it, to try it and understand a little bit of its, copy and paste some commands and then poke at it, which I think is it's a great opportunity in this stream because it's literally what we're doing here. And all of the decisions that like, if you were doing Kubernetes the hard way, or all the things that like, hey, I want to actually like run this, you know, in production, like those are all hard decisions that we had to make to package this up into something that's could run anywhere and also could be supported for anyone. And those are like 2 big things that are often missed in like how Kubernetes works if you're running it yourself. I mean, obviously like you get a provider, you go to EKS, whatever, and you handle all that for me. But there's so many use cases where it's like, no, I have vSphere, I have on-prem, I have whatever, and I need to run Kubernetes there. And so like we tried to really get that workflow the same and make sure it was consistent for if you're used to this tooling in this space, there's a familiar workflow through all of this.
Yeah. I agree that is working out pretty well.
And I saw one comment. Where'd it go?
Do you have a comment?
Russell. About how EKS Anywhere works. Like we didn't really talk about like just like where the components run or anything.
Yeah.
This is
we're going to get to that as we get this thing deployed. But yeah, but like we should definitely look in. If you want to do an overview now, I'll keep working through the doc here. But what I wanted to point out in this doc before I move forward, right, is that some of the spec information that we're generating are things like what cluster network is going, or how the cluster network is going to be configured. All right, and so we have a CNI. We picked Cilium for this. This is actually the way it comes. EKS Anywhere, whether deployed on vSphere or inside of Docker, it's going to deploy Cilium as your CNI. It creates a single node control plane. It creates a single node SD configuration and a single node worker node. And then as I deploy this here in a second, and Justin can talk through like how this will, how to conceptualize what EKS Anywhere is with regard to infrastructure. Then we'll get to see how it works at the same time. So go ahead, Justin.
And Carlos mentioned like why EKS Anywhere, and to Russell's question, EKS Anywhere is completely self-hosted on your own infrastructure. You don't even need an AWS account to run it. Like you there's nothing in this setup that we're running through right now, or to deploy it into vSphere that like requires you to even talk to Amazon or have an account. Like you're not logging in anywhere. This isn't sending data to us to like, connect back. There are some optional connections if you want to have, your on-prem cluster is connected to EKS. We have EKS connector for that. There's things that you could do, and obviously if you want paid support, you can call us and we'll support the clusters. But for like, I want to get started, I want to run this, I want to try this out, like everything in here runs on your infrastructure in your environment. It pulls from all of the, open source Amazon tooling. There's EKS distro, which is like actually like the bits that we build and run for EKS, the hosted platform. And that's like Kubernetes API server, that's the controller manager, that's the kubelets. We build those binaries with our own patches and those sorts of things. So it's pulling those things down from ECR, but those are also open source. If you didn't want to run those with EKS Anywhere, there's also a bunch of providers that give you those bits without needing to, like, again, use EKS specifically. And so EKS Anywhere is us saying, us as Amazon, we run a lot of Kubernetes clusters, in EKS. We make a lot of decisions about how those clusters run, how we operate those clusters, how we upgrade those clusters. And we wanted to provide all of the years of experience and tooling and decisions that we made to accelerate everyone else's Kubernetes path. And that's, if you're on-prem and you also want support, if you have business critical workloads, you should probably pay for some support. EKS Anywhere is us taking our architecture for EKS, our decisions of EKS, and putting those into your own environment without requiring you to run anything on AWS. So it really is, a lot of people get confused too with ECS Anywhere. ECS is another container platform that Amazon has. ECS Anywhere runs worker nodes on-prem. The control plane stays in AWS. You have to have an AWS account. You have to have an ECS cluster. You connect worker nodes back to that control plane, and they have a tunnel that schedules jobs and does everything else. So if you want like a lower barrier to entry of like, hey, I just want to run a container. I don't want the control plane. I don't need a disconnected state, those sorts of things. But for EKS Anywhere, you could disconnect your internet. I mean, you have to pull images and that sort of stuff, but like everything runs on-prem. If all of a sudden like you don't have a connection to AWS, that's actually okay. Everything is in your infrastructure and is running as Duffy will show up. Like it's cluster API with, a bunch of tooling on top of that for decisions we made.
Mm-hmm. That's awesome. So what I've got so far, what I'm looking at here on the console here is I've also installed Kind locally, and I've got 2 Kind clusters that have been created effectively. There's one that's actually called dev cluster, and there's one that's called dev cluster EKS-A-cluster. And what we can see from the log output of the EKS Anywhere create cluster command is that it has created a new Bootstrap cluster, and that's that dev cluster EKS-A cluster. It's installed the cluster API providers and configuration into that Bootstrap cluster, and then it has used those tools to generate a new workload cluster. And then as we progress here, we're going to see that change a little bit, because as part of bootstrapping cluster API, generally, especially in like a local mode like this, we give the cluster the ability to sort of manage itself. So we're going to play a little bit with that, how that works.
And,
go ahead.
And the Bootstrap cluster, like when you run an EKS control command to create a hosted EKS cluster, Amazon has a lot of infrastructure that we can rely on and say like, oh, how are we going to create that cluster? On-prem, on your laptop, like you don't have CloudFormation, you don't have S3, you don't have like all these other tools. So we wanted to build this Bootstrap cluster to allow you to just like, hey, we got to bring some infrastructure first in order to like create this and make sure this environment exists. And it's the same workflow if you've used Cluster API. There's a Bootstrap cluster. A lot of times those turn into management clusters. You can like shift your workloads over to it. But the idea is not to keep your workloads what you actually want to run for your business, with this like initial creation cluster of like, hey, we want something that we can kind of throw away. So as Duffy was saying, like that Bootstrap cluster gives us the components, we generate the YAML, we shove it in there, and then that actually talks to our provider APIs.
Exactly. And the way that it does that right now, because our provider is Docker, is you can see that basically, if we did a little bit more introspection here, then the cluster that we're spinning up and the Bootstrap cluster both have effectively mounted in the Docker socket. And it's using that Docker socket to generate all of the equipment, all of the infrastructure for these clusters. And the way it would work through, it's basically treating that Docker socket like the infrastructure API that you would interact with. So if you were to leverage vSphere as a provider, instead of hitting that Docker socket, you'd be hitting that vSphere API and making very similar calls, like how do I create the network? How do I put the nodes up? What image am I using as a base for those nodes? Like what steps do I have to take on those nodes to make them a part of a cluster? Like in since we're still using kubeadm as another great open source project, since we're using kubeadm to do the bootstrapping of Kubernetes on all of these nodes, then as part of the kubeadm control loop that runs inside of your management cluster, it's actually going to connect to each of the nodes as they come up and become healthy, and run whatever is important from kubeadm's perspective to join those nodes to the cluster or to identify them as how they are. One of the things I've noticed also in this cluster, which I thought was pretty interesting, was, let's just go back to our cluster YAML real quick, is that we're using this mechanism also, and I pointed this out earlier, but like the way, actually I haven't pointed it out yet, but this is a way to create an external etcd configuration, right? And so when you use this mechanism within cluster API, then you will get control plane nodes, you will get worker nodes, and you will also get an etcd node or multiple etcd nodes depending on how you configure things. And so I thought that was an interesting, as part of the decisions that you made, at AWS about how you wanted to have this how you wanted this to be created.
Yeah, and again, that's how, the architecture for how we're running EKS clusters is not with one, but we separate out where's the database, where's etcd, where's the control plane for the API server, controller manager, and then where's the workloads actually happen. And in EKS, we found that being able to scale control plane and etcd independently added a lot of value, just to be able to make sure that it was highly available, it was performance, all of those things that were required for production clusters as a service. We wanted to bring that into this tooling as just a default. You can turn that off and you can have etcd run on your control plane nodes as well. But by default, we wanted to give you something that we thought was how we like to run it, how we saw a good experience, and within Docker, maybe it doesn't matter as much. But for vSphere, you're going to get 3 etcd nodes, you're going to get 2 or 3 control plane nodes, then you're going to get your workers. And being able to isolate each of those components that are critical to the cluster running was important.
That's awesome. Yeah, and then this is the output I was talking, where we can actually see the nodes. So from kubekttle's perspective, there are just the 2 nodes, a control plane node and a worker node. And then if we look down at the output of kind get nodes, we can see that there are 4 nodes, right? We can see this etcd node that has been created. There's a load balancer that's been created to basically load balance over the control plane if you decide to scale this up to multiple control plane nodes. That way, when kubekttle interacts with your cluster, you're going to be load balancing across those API endpoints. And then there's also this is the control plane node, and then this is your worker node. And the names all line up, so it makes it pretty easy to kind of see what's happening here. So the output of these 2 commands, the first one is kubekttle get nodes. The second one is kind get nodes with the cluster name already kind of embedded into the environment. And so we can see all of those things running, which is pretty interesting. So the next thing I wanted to do was just kind of look around the cluster a little bit and see what we see. So we do get pods -a. So this is an empty cluster that's just been deployed as part of the configuration. And we can see a couple of different interesting things here. So as part of EKS Anywhere, it actually spins up and migrates the all of the resources that the Bootstrap cluster created. So when these new nodes were created, the control plane node, the etcd node, the load balancer, all of that stuff, those were instantiated by all of these controller managers inside of the Bootstrap cluster. And then once they were all running, the last step as part of the log output here, which we saw right here, is that we spun up a new workload cluster. We then installed all of the cluster API providers into that workload cluster. And then we moved the state. We moved the state for all of those resources that were developed or that were instantiated by the Bootstrap cluster into the workload cluster. And then we install a bunch of EKS or EKS Anywhere custom components into there. And we can take a look at that CRD and the controller in the workload cluster. And then it creates some CRDs for them. I haven't looked at what those are. And then it installs the add-on manager and the Git Ops toolkit. Do you want to talk a little bit more about what's happening here, Justin?
Yeah, right now those are fairly basic with what they provide. We have some documentation on Git Ops, which is using the Flux controller from Weaveworks. So we were working closely with with Weaveworks early on to say like, hey, we want to enable customers to be able to do a Git Ops style workflow. Not everyone, once they have a cluster, knows how to now manage that cluster for a lifecycle. And Flux and a Git Ops model of saying, hey, we're going to push these configs into a Git repo, and then Flux is going to pull those down from GitHub, or right now it's GitHub, but wherever you need to host it in the future, and actually apply that state to the CRDs. It's a lot of people are like, oh, I have CI/CD. If you have Jenkins, if you have something else, like you can do some of those things too. Look into Git Ops as well, because the controller running in the cluster adds some benefits for security, adds some other details on top of that. That's not just a standard like kube control, like put all these configs into the cluster. So that is something that by default it's off. It's an option there. And then add-on manager is just another piece of, we want to add more features in there and make the cluster a little more full-featured for whoever's using it. Because you have a cluster running, but you don't have a metric server. You don't have, a load balancer controller. You don't have like specific things that you might actually need for your workloads. And so we want to be able to have add-ons that match your, Kubernetes version and say, hey, I've run into it in the past. I'm sure there's plenty of people out there have run like, hey, this version of core DNS doesn't support that version of Kubernetes, and like keeping those things in check and making sure that like deployments line up with the APIs and all of that stuff is important for an add-on manager to do. And so we want to add other options that say, hey, how are you running metric server or whatever inside the cluster? Those would be, you can define those inside of that spec in the future to be able to like run those, and the add-on manager will pull down those images and do it.
That's awesome. One of the questions from Russell was, does that mean that etcd machines aren't actually Kubernetes nodes? My albeit simplistic view of Kubernetes was that a node had a kubelet on it, and that was behind a role. Now, what's interesting here is that like you could kind of have a little bit of both worlds depending on how you do it. What the decision that the decision from EKS's perspective is that the etcd nodes should be separate from the cluster, so you can have that state kind of external to the cluster and manage the upgrades of those things kind of in an external way, right? And so when we do a kubectl get nodes, we don't see the etcd node running here, and that's because there is no kubelet running inside of the etcd node. In fact, if I exec in or, kind of like SSH into that node.
You should clear your screen or the comment.
Oh, yeah, probably a good idea. Okay. So what I'm doing here, I've execed into the, let's just clear it. I'm going to jump into that etcd node that's been created, and it's running as a Docker container because we're using the Docker provider. And inside of here, I can do systemctl status etcd. And so this is running as a systemd unit, and it was configured by etcd ADM. And etcd ADM is tooling that basically goes out and fetches the necessary binaries. It figures out what the configuration of etcd will be in a relatively secure way. So it turns on all of the TLS stuff. It generates this. It asks for the CA key to be generated. It configures the servers and all of that stuff, and then it provides inside of Cluster API. It basically exports the information needed for the API server and all of those to communicate with that etcd cluster, and makes that available as both a config map and a secret, depending on whether it is actually the certificate or whether it is actually just the configuration of the etcd cluster, so that the API server can then be programmed to interact with this particular etcd node and etcd cluster. But there's no kubelet running here, right? If I do pgrep -a kubelet, I would expect that there be no kubelet running. Instead, it's just etcd running on this node. And then to Justin's point, if we configured Cluster API in a slightly different way, by default, Cluster API will co-host them, right? It'll basically spin up etcd using a static pod manifest, the same way it spins up the API server and the controller manager and all of those components, right? And so it would actually run one etcd node on every one of your control plane nodes. Actually, run one etcd instance on every one of your control plane nodes, and it would use the underlying disk as the durable state for those etcd nodes.
Yeah, and in this case, in Docker, you can Docker exec into it. If you're using vSphere, you can still SSH, like you can define keys for the, for the nodes that are running etcd, and you can SSH into them, and you can, manage the machines that way. But to the point of like, Cluster API by default will create the static manifests and run etcd inside of a pod that the kubelet creates. And in this case, we're just using systemd, and we're taking out some of the like trail of, system on a Cluster API node. Systemd starts the kubelet starts the static pods starts etcd, and in this case we're just separating that out and saying, actually, like, systemd is really good at running databases, and we don't need the kubelet on here because we don't actually want people to accidentally break things with the database, because that's actually like super critical. Where your data lives in etcd is like the most critical piece of Kubernetes, and so separating that out allows us to, if you need to scale etcd, if you need to upgrade etcd, if you need to do something like that, you can do it separate from the control plane nodes. It doesn't mean that like it'll always exist that way, but again, we wanted to make some decisions that we saw as our best practices for EKS in AWS.
Exactly. Another question by Russell is, if a platform provider, let's say Amazon, started providing etcd as a service, we could use that and not have to manage etcd running on any of our Kubernetes nodes. I mean, and if you squint a little bit, that's kind of like how EKS works, right? You're not managing that etcd service. But what's interesting, and I wanted to compound on this point, right, is that the reason that EKS works that way, and like a lot of the Kubernetes as a service offerings include the entire control plane, not just etcd, is because etcd is also somewhat latency sensitive, and so you want to make sure that you're hosting that etcd really close to your control plane, and that you're taking into account like the failure domains for all of the things when designing that. So if you although you could, I mean, I have seen some interesting models where people are using like a remote database for hosting Kubernetes resources. I wouldn't say that any of them have really risen to the point where etcd is in that ecosystem today, right? And so instead, what you see are tooling like Cluster API and EKS Anywhere, where the tooling is responsible for managing the lifecycle of that etcd cluster for you, but it will also ensure that etcd cluster is deployed effectively in parallel with the other resources that it is deploying for that cluster that it is creating on your behalf, right? And so in EKS Anywhere, it's going to create your control plane, it's going to create that etcd cluster, it's going to create all of the worker nodes that you need to manage, and it will handle upgrades, and it will handle scaling. And that's actually the next thing I wanted to play with a little bit, is play with like what lifecycle control means, and actually dig into things a little bit more.
Yeah, there's a fairly tight coupling there between etcd version and Kubernetes API. And so how etcd is configured, and as you mentioned, the export of kubeadm into, the Kubernetes API server is like, they need to talk to each other. They need to be able to like change certificates and know about that sort of thing, or do upgrades.
Yeah.
And having that in the same lifecycle helps in a lot of ways, but also separating it a little bit so that it can be managed or isolated if I don't need to update etcd. I don't have to. I can just I can change my control plane nodes. I can leave etcd as is, and then we can, reconnect as new nodes are coming up. So all that stuff are just like separations of concern. A lot of times, big companies will have the database team, right? And like they want to know information. They might have a different way of backing up. If you need to back up etcd, this is running on your,
a variety of ways to do it. Yeah.
On-prem, your DBA say, hey, how do I SSH into etcd? Because I need to make a backup. That's their responsibility to make sure the database is backed up or something if it needs a restore. And so the tooling can help with, automating upgrades and scale, but EKS Anywhere is not doing backups for you. It's not doing something offline. That is still responsibility of the cluster admins or the DBAs. And in this case, having it separated actually gives them, hey, like, I don't want a DBA on my Kubernetes control plane. And if they, if they're running Cluster API, if we're running it with Cluster API with embedded static manifests, like, go tell the DBA, well, go first look in the, kubeadm, or the kubelet folder, find the static manifest, find the container, now exec into the container, now get your dump from that. Like, it's a lot more steps involved there. And so being able to like isolate that as like a more standard way to run a database also helps with some of that maintenance.
Yeah, it's also, I mean, we've made the argument in the community a number of times, but hosting a kubelet on a node where you're also hosting the etcd database is is a security problem, right? And you might have to really consider that because, for example, like for the most part inside of Kubernetes, you can't consider scheduling a security boundary. So you can't say something like, well, if I have a kubelet there and I'm just hosting etcd, then I'll just taint the nodes and nothing will be able to schedule there. That's not a thing. Instead, for the most part, somebody could actually just populate the node name on a pod spec, and it will schedule that, and that pod will just get instantiated by that kubelet. The scheduler never even sees it, right? And so now, if you could do that with hostnet on that node, on that node where etcd is running, the kubelet is running, then you also have the ability to take a look at that underlying file system and maybe get the unencrypted backups, if there are any unencrypted backups from that underlying node. So there's a really good security argument also for keeping etcd off of the control plane nodes, because you may actually have really good reasons for wanting the control plane nodes to be exposed for things like metrics, for things like understanding the utilization of the control plane nodes for monitoring and all of those things, because we already have all of that wired up really effectively in Prometheus. But you'd have to consider carefully whether coupling them together is a good move or not.
And Carlos points out like gatekeeping DBAs on the Kubernetes nodes. I mean, the DBA doesn't want me on their nodes either. So
Probably true, yeah.
And I don't like, people have expertise, and I know it's a joke, but like that really is like as you scale a lot of these clusters and your company scales with their expertise, like you're gonna get focuses, and you're not necessarily gonna have you can't have a deep generalist, right? Like you have deep expertise or you have broad, generalists, and being able to like, I can dabble in etcd, I can dabble in some databases. I don't want to be responsible for them in prod. and it's just kind of that separation for what people are good at and what they're able to focus on, and to the security point and everything else, like how you're gathering that metrics, like toolings build boundaries, and my tooling for etcd is probably going to be different, is different than my tooling for kube control or the Kubernetes API server. And so being able to isolate how those tools work and how they're secure and, who has access to them is actually really important in big environments.
Yeah. So what I've run here is I've run a command that basically, I want to actually change my command a little bit. Anywhere. Here we go. So this is me just evaluating from the Kubernetes API resources that have been registered with the cluster. So these are things like CRDs, but objects that basically extend the Kubernetes API in a way that I can configure them as a Kubernetes administrator. And I wanted to see like what came from the anywhere.eks to amazon.com family to see what was in here and take a look around at what's happening here. And so we can see AWS data center configs. There's a bundles group. There's a clusters group. This is actually part of the Docker data center. This is part of the Docker provider integration. So these things up here, I imagine, are also part of the Docker data center or part of the cluster API integration as part of EKS Anywhere, just hosting a different CRD than the open source cluster API mechanism for it. But then we get into more interesting stuff like this Git Ops configs and also OIDC configs. So these are very specific to the Amazon integration. These are features that Amazon has developed and delivers as part of a mechanism that could be extended into the cluster when that cluster is instantiated by EKS Anywhere. And I did see in the web interface or in the docs information about how to play with that kind of stuff, right? So here's manage cluster with Git Ops, and that's actually going to be part of this integration here. And then there's also a mechanism for authentication, which I don't see immediately here. Must be somewhere else.
Sorry, I sent a link in the chat for like the actual reference to the specs is under, if you get out of the tasks top menu, there's a reference submenu with configs. So you can see the spec of like a full, every option available.
Did you send that in?
I'll send it in private chat. Yeah.
Oh.
There you go.
Perfect. Oh, nice. Oh, there we go. So this is actually defining the the spec. This is the unstacked SED topology that we've already kind of talked about. So that's the cluster. This is all assuming the vSphere configuration, which is fine.
Right.
Here's the OIDC support. So EKS Anywhere can create clusters that support API OIDC authentication. And this means that if you have, I believe it means that if you have an AWS account, you can configure your cluster to allow AWS authenticated users to interact with resources in these target clusters.
I don't remember if it is available right now, but I know we would like to make, if you have an OIDC endpoints with the certificates, like we have a lot of requests for I need to auth with OIDC, and it doesn't necessarily, it's not always AWS, so I know that would be a feature request for enabling that for anyone that has OIDC if it's Okta or something else, and
Nice.
you say like, oh, all of my auth goes through this. We would want to be able to enable anyone running this with whatever OIDC provider you have.
That's very cool. What's neat also about this is that like you're documenting what is actually available inside of the API. So this is one of the other commands I ran, is that like I wanted to evaluate this cluster to see what was here. And I can see that there is a Git Ops configs. So if I do kubectl explain ops configs, then I hit the wrong button, of course. So I open a new tab. You can see exactly the shape of this API object, right? We can see what would actually be, what are some of the things, some of the fields that we can actually specify. And then if we wanted to know more about something down here in the spec, which is usually where some of the good stuff is, I can actually explain, I can do another explain command that shows me like that depth, right? So I can do kubectl explain. And it provides some explanation for those fields. And this output is basically what's encapsulated on the web UI, which I thought was actually pretty cool. A little bit more of a description, of course, but these descriptions are actually all part of the API spec. So good stuff. Self-documenting things. I appreciate those.
Yeah, and I mean, not everyone knows to turn to describe to like find those specs and to like really poke at it. And so like when I learn a lot of things, like I still remember back when I was early learning Ansible. Right, I was learning it as a tool, and the very first thing that I found on GitHub was someone had an Ansible file, just a plain YAML file with every option. At the time, it was really small. It was Ansible was new. It was like really cool. Every provider with every option with a comment of documentation. I referenced that for months of just like, oh, let me find what that was, and like there wasn't a CLI to do it. There wasn't really an easy way to explain it unless you dug into the Python. And in that case, I was like, you know what? Like ever since I've done that, I learned the benefit of actually having a browser tab open, my terminal here, and being able to switch back and forth with them, and Control F, in my in my browser versus like keep reloading the config or something like that, or even browsing plain text. Sometimes browsers are just really nice for people to get started and learn.
Mm-hmm. That's true. Let's take a look at scaling this cluster and playing with it a bit, and then I want to kind of explore a little bit more on the Cilium side. So I'm back in the docs here, kind of talking about scale the cluster. It looks like there are a couple of different ways to do it. There's a manual way wherein you increase the number to change the values. And then you would use the EKS Anywhere upgrade cluster to actually make that change. And then there's semi-automatic scaling where you can manage the cluster with Git Ops. That may be fun to dig into. I'm not sure we have enough time in this session to dig into it, but I may actually explore that in another session. And then we have automatic scaling, where now that there's, I remember like some of the working on this for some time, there's already a pretty well-known open source project called the Kubernetes Cluster Autoscaler. And so if you have a cluster that has been deployed in a way that can be supported by that autoscaler, and it supports a variety of different targets, whether they are whether you're hosting your own stuff on EC2 or hosting like your own stuff on GKE or an Oracle Cloud. There's a variety of different mechanisms that the cluster autoscaler can manage, and the autoscaler will basically determine the load on those clusters. Like, are you actually seeing the scheduling latency increase because there's too much work to schedule and you don't have the resource, the node count to actually support it, then it will actually make the call to that instance group or what have you, and actually scale it up so that you can actually have more of those instances come online automatically and do that. And with the recent changes, now we have that for Cluster API. So if you had the Cluster API or the Kubernetes autoscaler, you can configure it to use Cluster API as a target, and it will do the same thing. It will just basically measure the scheduling latency. If it sees that increase to a certain point, then it will actually spin up more worker nodes or another group of workers, what have you. That's actually all pretty cool.
And I will call out here, these three modes were like, manual is I'm going to run it at the CLI. Like I'm going to do something, especially like in on-prem environments. If you have bare metal, like you may not be requiring like auto scaling. Like that's not a thing for you unless you go open a PO and someone racks and stacks the block. And like you don't actually need automation in some cases. And so like at that point, it's like, hey, you could manually auto scale this thing and provision something else. The semi-automatic is I'm going to edit a config file and my Git Ops controller will actually do the thing for me. Automatic isn't supported yet in EKS Anywhere because of the controller. Because of Cluster API and because of controller. So we don't have an add-on that's actually adding, the autoscaler at all. So like that's not something, if you read the little paragraph there, like it's coming. We know people that would want it, especially depending on the provider. In a vSphere environment, it probably makes sense. In a Docker or a bare metal, it probably doesn't make sense. So on-prem is different than hosted in a cloud where, you can spin up another node without a problem. Like that's not so easy a lot of times, even in vSphere for some environments. Like I've been in plenty of vSphere environments where like the way I auto scaled was I emailed someone. My email was my API to go like, hey, I don't have access. Like that's like separation of concerns. Like, can you add this for me? I'll, do whatever I need to with config management or whatever to add it back to the node. But like, that's my auto scaling. So those are our three options. If you do have Git Ops and you're in, a provider that supports it, like you can change a config file and it'll do that for you. But in most cases, like if you're doing bare metal, it's not something that's easy to do necessarily.
That's fair. Yep. And actually what's interesting about this is that, it falls right into that second category of thing that you documented, right? Which is the semi-automatic, where you're leveraging Git Ops for these things. So in this case, what I've done is I just made a modification of the definition of the cluster, right? So this is our defined cluster. And what I've done is I've just changed the number of control plane nodes and I've changed the number of worker nodes in these configurations, right? And so if I go ahead and apply that, then you can imagine that there would be some controller or some reconciliation process that would evaluate the fact that the definition of this cluster has changed, and then would do effectively this very same command line with that new file and operate that change and report back on whether it was successful or not. You can do this all in like a Git Ops workflow,
And in the manual mode, it's still going to do the similar thing that we had for the Bootstrap, where it's going to create a kind cluster to bring in the controllers, understand what's going on, and then talk to the Cluster API endpoints. In the Git Ops model, you're not actually creating that Bootstrap cluster again, because the controller's running in cluster with the CRDs and the controllers that exist for that cluster. You don't have to go through that step of, I also need a Bootstrap cluster to then figure out what my difference is and to figure out how things are applied. So it does make things faster to do the Git Ops model because the controller exists, the Flux exists, and the controllers for it already exist. In manual mode here, we have to create a kind cluster. We have to understand, okay, what's going on? Let's bring that infrastructure down to make sure we can run this command. It's not just necessarily like modifying the YAML in the live cluster.
Yeah, although it could be, and after we get done with this, I'll show an example of that. We'll scale the workers back down to 2 afterwards, and kind of show how that would work from something within the scope of the cluster, being able to do this stuff. Yeah. But this upgrade will take a minute while it works through its magic. So we'll let that happen, and then the last thing I wanted to cover in this session was getting Cilium from the Cilium that has been deployed here into a different deployment of Cilium. So usually these sessions are a lot more about eBPF and things happening in that space, but I'm having a bunch of fun kind of exploring the Cluster API stuff and how all of this is working. So pretty exciting stuff.
And I know there's a lot of people that like Cluster API is brand new. This isn't something that I see many people running. So in this case, EKS Anywhere, we really are trying to like help make some of those decisions, because it's a great project that enabled a lot of things to say like, hey, if I liked deploying a pod or a deployment, I like that workflow. Like Cluster API is doing the same thing for clusters, essentially. If you've run it yourself, it actually has a lot of moving pieces, just like Kubernetes. And so EKS Anywhere, again, is just trying to like help make some of those decisions, help figure out like how to architect it, how upgrades should work, how that flow should work. Cluster API does a lot of that stuff. But there are still some pieces in there of like, hey, how do I want to do this? To your point, like having the CNI be one config file of like, oh yeah, we're just going to install Cilium because we saw so many people love Cilium on-prem. It adds a lot of benefits inside a cluster for, observability and for security. Let's figure out like how we can make that as simple as literally one line in a YAML file and it's there and ready to go.
Yep, I like that. So here we're working through the process, which says it's going to make sure that my Docker provider is working, and it is. It's got it is able to detect that my control plane worker nodes and the other etcd nodes and stuff are all in a ready state. They're all healthy. It checks the CRDs to see if everything's in a good shape, and then it begins the work of doing the upgrade here. So it's going to actually spin up another cluster. So if I were to do that kind get clusters, you can see that we now have two clusters again. We have that EKS A cluster back, and that's that Bootstrap cluster that has been created again. And that happened right here in this step. And then we throw all of the cluster API provider components back on that Bootstrap cluster, and then move the state back to the Bootstrap cluster, modify or make changes to the existing cluster using that Bootstrap cluster as a remote control. And then once that's back in a healthy state, we move all the state back to that workload cluster. And that's exactly what Justin was just describing. It's actually pretty cool. So we do kubectl get nodes -a -w. You can actually see these things happening, right? So this is the process of spinning up new nodes. So we've added 2 new workers and two new control plane nodes. If I do kubectl get nodes, you can see that we've just added. The 2 workers are already added. They joined 67 seconds ago and 63 seconds ago, already ready. So Cilium is already deployed on them and working. Now we're waiting for that 3rd control plane node to get picked up.
I'll also point out that the way we're currently managing EKS Anywhere clusters is a 1-to-1 mapping of cluster API components inside the worker node itself. So this isn't, if you're creating a Kubernetes cluster as a worker node, it also is running these CRDs and CAPI controllers to be able to provision itself and manage itself. There is another model that Cluster API recommends for a lot of people, is a management cluster. So you have a dedicated cluster that only runs the CAPI controllers that talk to the different providers. And in a lot of cases, that's like the default you get for a lot of situations if you're running Cluster API. We don't currently have that in EKS Anywhere. We do want to allow that to be an option for people, because that would also limit some of this Bootstrap cluster need over and over again. In that case, you could talk directly to the management cluster, figure out what CRDs are needed, and then use your controllers to go provision or scale or upgrade the cluster externally. And to your point earlier about etcd and the control plane, that also helps create security boundaries between, hey, who has access to manage the cluster and who has access to add workloads or run things inside the cluster. And so having a management cluster also separates out those things too. It's not there right now. Right now it's a 1-to-1. So we don't, initially we wanted to get it out there. We want to get a lot of feedback. I saw some people asking about different providers. We're definitely working on more providers for EKS Anywhere. So right now it's Docker and VMware because that's what we, Docker to try it out and let people play with it and learn, and VMware because we saw a lot of on-prem environments that had VMware and wanted to utilize those investments because they're like, hey, we have a lot of expertise in VMware. Please don't make us go learn, another thing. We have, third-party integrations, storage, backups, all this stuff built into VMware that they're using and taking advantage of. And in a large on-prem environment, we wanted to let people take advantage of that. So VMware was our first provider because we saw it everywhere. But other providers are definitely coming.
Perfect. Yeah. So now the upgrade is complete, and all I did was make a change to the definition file and upgrade to it, and now it was able to do it. If I had made a change to the version of Kubernetes, it would also update that. One of the questions that had come up that Russell asked was, are there any customizations to the Cilium config that EKS prefers to use, or is it pretty much a default Cilium install? And it's pretty close to a default Cilium install. It is a slimmed down version that basically just makes it like the bare minimum that we could deploy and get everything working with. And so it doesn't have things like the Hubble integration and stuff like that. But that's the next thing I wanted to explore and kind of play with that with you all and kind of show how that stuff works. So let's get into that part of it. Before I do that, let's answer Carlos's question: how Cilium got installed and configured on the new nodes again. So the way that works, it's just like it would work for kubeproxy and some of the other components that are running inside the cluster. If I do a get ds-n kube system, you can see Cilium and kube. Oh, darn it. Yep.
Clear the comment.
Thank you. So we have Cilium and kubeproxy running here. And this is running as a daemon set, which means that as I add nodes, I have more nodes on which to put this daemon, right? Because daemon sets don't care about they don't care necessarily about a node selector or anything else like that. They're targeting pretty much any node that is known within the cluster. So if you do kubectl get nodes, by default they're going to target anything that isn't tainted. So any node that is not tainted, your daemon set will apply to it. And then we're doing that with the network with Cilium and also with kubeproxy. All right. So what I wanted to show you here was what's here. So if we do Cilium status, we're using the Cilium CLI command to interact with the cluster here now. Because we already have kubectl configured, it's already up. We can see that we have Cilium installed, that we have the operator running, that we don't have Hubble running or cluster mesh running, that there are 6 nodes and all of them are running and that everything's in a healthy state, and that we're running a build that we put together for the EKS Anywhere folks. And it's running the version 1.9.10. And so I wanted to show how to get to the OSS Cilium here. So let's play with that a little bit and see how that works. So the Cilium CLI, before I jump into exactly what's happening here, I want to show you where that is. If you go to docs.cilium.com, we now have a couple of different installation methods. We have a method that could leverage the Cilium CLI, which is the tooling that I'm talking about here, which is a part of the Cilium OSS tooling. And then we also have a method that leverages Helm, depending on what you want and on how you want to manage and what you're managing. But the OSS product has basically moved completely to now the Cilium CLI mechanism. So if you want to try this out, there's actually some pretty neat features inside of the Cilium CLI to engage. And if you have questions about it or if you have challenges with it, remember that you can always come and chat with us on Slack and interact with us from that perspective. So if you're interested in exploring Cilium, the open source project, definitely check it out. And this is the way you go to docs.cilium.io. There's some great quick starts to get started there and all of that good stuff. But let's play with this a little bit more. If I do... so this is what we have so far. So let's play with it a little bit more. What I'm going to do next is I'm going to go ahead and move this to the Cilium OSS configuration for this cluster. And when I do that, I'm actually going to be doing some kind of disruptive work within the cluster, and we'll see how it works out, right? So I would recommend that if you were going to do something like this, you would be in a maintenance phase while you're doing it. You're not expecting workloads to continue to work while you're doing something crazy like messing with the underlying CNI.
Basically unplugging a network cable on your box, right? Like this is
exactly.
as destructive as that. It's like, hey, the pod, like, oh, no networking for a second. Hold on, we'll be back.
In fact, that should kind of tell you already like that we're doing some kind of crazy stuff here, right?
Fire.
So I'm going to start with a Cilium uninstall command. And it's actually going to remove a bunch of the configuration that is already in the cluster for Cilium. And if I did a kubectl get pods -n kube system, I can see that there's no longer a CNI installed. Now, some of the stuff will continue to operate because the machinations of wiring all of this up are still in place, right? So the eBPF programs may still be there. The configuration that actually provided the VETH interface for that is still there, that sort of stuff. But we can see that core DNS now just kind of went unhealthy, and that's because the underlying CNI bits are actually been removed. So let's play with this a little bit more. Let's do Cilium install. Again, kind of like what Justin said, we wanted to make it super simple for people to get to this point. So we just made it Cilium install. That's how you get Cilium on your cluster. If you come up on a cluster that says all the nodes are unready and there's no CNI deployed, you can just do Cilium install and you will get Cilium installed on it. One of the questions that Carlos asked earlier was how easy is it to install Cilium in kind? And effectively, that's what we're doing here. And as part of the intelligence of the Cilium agent, when it's coming up, it does a little bit of introspection on the cluster that it's being deployed into, right? So we understand like what, whether we're using EKS or Azure, we understand if we're inside of a kind cluster. All of those things we are able to detect. And if we're inside of a kind cluster, then we modify the configuration a little bit. We modify the configuration flags for the kind cluster to make it as compatible with the kind environment as we can. Things that you might want to consider when deploying into kind, especially for our case, right, is that remember that kind is Kubernetes and Docker. That means all of these nodes that we've been playing with, scaling up and scaling down, these are Docker containers. So when I scale up the machine deployment, I'm actually just spinning up new Docker containers, inside of which is running containerd and kubeadm and all of those bits in Kubernetes. And because they're Docker containers, they share the same Linux kernel. They don't get one Linux kernel per node like the way you would normally think of infrastructure. They have one shared Linux kernel. What makes that, why that's interesting is that effectively you can think about the fact that each node is really just, its entire network stack is inside of a network namespace, which is a primitive that is exposed by the Linux kernel. And so Cilium has to be smart enough to realize, okay, well, in this world, each node is its own network namespace rather than a different node. And we're all sharing context of the same Linux kernel, rather than just understanding the context of each of the kernels that are a part of a deployed set. And so we have to think about, you know, how we access that data and what view we have of it a little bit differently. And that's why we kind of changed things a little bit. So it looks like things worked. I'll get pause session. You can see our core DNS is back to healthy. It restarted a few times while we were having a long dark tea time over the soul with no CNI. And that's all working out pretty well. So the next thing I wanted to play with was just kind of turning on some of the other features of Cilium. So let's do an UI. Hubble enable. What this will turn on is this will turn on a feature called Hubble, and it will wire up the Hubble relay so that we can do things like observe traffic without having to work on things like PCAP or wire traces or anything stuff like that. Instead, we kind of have a global view of all the traffic moving back and forth between all of the nodes and all of the applications, and we can actually kind of see, like, you know, from that sort of like Wireshark level, we can see what's actually happening from connectivity perspective. So let's take a look at that real quick. Cilium status. Hubble relay has been deployed and it's successful. And then
is it Hubble UI?
You know what it might be. Yeah. Make one other deployment, which is going to turn on the Hubble UI, and then we'll play with that as well. So at this point, now we have actually just moved from the Cilium that is installed as part of EKS Anywhere to the open source Cilium, and we have a bit more feature. We have a bit more feature breadth set. So we can do things like the Cilium connectivity test. which will basically validate that all of the things are working the way we expect. While that's running, I'm going to go ahead and pop open another session here.
Oh, also, Carlos asked if there's something special about the Cilium we provide by defaults in EKS Anywhere, and we partnered with Isovalent on. Obviously, hey, we would love to use your CNI inside these clusters, but also the builds themselves are validated and built with Isovalence. Make sure that they're compatible with the clusters we're rolling out, and it really is a lot of it's just around support. Like, we need to be able to know what the bundle is that we're installing, what the cluster entails for that support. And so that version of Cilium gets built and validated through all of our tooling for EKS Anywhere to make sure that it can be supported by us. If you have a cluster, you have paid support, you can call us and we can help you troubleshoot all those things. If you wanted to, say, upgrade to Cilium Enterprise or whatever, like, you could go that route and then talk to Isovalent to get that support. It just not necessarily wouldn't be supported by Amazon anymore in that case.
Exactly. I think I have an old version of Hubble or something. Let's grab a new version of Hubble. One second. So I'm actually going to use the Hubble command line, and so I'm going to do Hubble install. And this is from the docs.cilium. And again, just like we were talking about earlier, just copy and paste.
Looks like I already turned it there. Yeah, it should be good.
All right, there we go. So we have a bunch of tests running in the background, and we can see that traffic moving back and forth between different components. So Hubble Observe gives us that ability, that kind of like granular view of the world that we were just talking about, but with a lot more context about what's actually happening, right? So we can see traffic that is coming from an IP or coming from a node inside of the cluster, going to an IP that is known to be outside of the cluster, probably DNS. Probably, I'm not sure what 192.168.3.253 is, but whether things are forwarded and those sorts of things. We can do, let's do namespace, Cilium. So we can see in this configuration, the tests that we're running, right? We can see the actual transport of traffic moving back and forth between those things. We can see stuff that was dropped and why it was dropped, policy denied. We can see communication back and forth between all of the different components within the cluster. And we can do this without Wireshark. And we can see also this from the perspective of a global view, rather than thinking of it necessarily as how does traffic move back and forth from this particular pod on this particular node. We can refine to that view, but like right now, where I'm looking at all of the traffic in the namespace, regardless of what node that traffic is on, this observability basically gives me like a global view of what's actually happening within the traffic of the cluster. And the other neat stuff is that we can see the when things are dropped, we can see why, right? We can see.
Interesting too, as you were mentioning, doing this on Kind, because they're all containers, they actually share one eBPF app inside the kernel, because it's one kernel, so we only have it installed. We only necessarily need it installed once in this context, but it still identifies the different sources of those namespaces as nodes because they have their own IP address and everything else. So
exactly.
And actually, random question for you. I don't know if this exists. Is there some sort of like, I want an eBPF top. Like, I want to be able to know like what eBPF programs are running on my system, because I don't know of a way right now to like view that globally. I mean, like, there's specifics for which tools installed which eBPF applications, but I would love to just know, like, show me all the tools, what they're running and what they're doing. Is this it?
Yes.
Nice.
Need to install one more thing.
You need kernel headers or something? Tools, cloud tools.
This is basically just installing BPF tool, and BPF tool is kind of like a Swiss Army knife for this stuff. So actually, in the beginning of the episode, I did actually talk about a great blog post by Quentin, who I think that you would really enjoy, Justin, which is right here in the notes that digs into kind of almost answering this exact set of questions, right? But the one that, and actually I think he even covers it really soon. So BPF prog dump will actually drop all of the programs that are running inside of your cluster that are BPF programs, or within your node, or inside of your kernel. So BPF tool, prog list, root, of course. But these are all of the BPF programs that have been inserted inside of this particular node. And you can imagine this is probably a bigger number than would normally be, because to your point, right, this is all of the BPF programs that we would inject in every namespace for every node for related to traffic and network policy that we define within the cluster, right? If you were to bring up a completely empty node with nothing running, you would see nothing in here except for like maybe a couple of different things. But this is the view of all of the different programs that are in here. And then if you wanted to dig into a little bit more of what is actually happening for a given program, so these are different. This is probably one of the. These programs can get pretty hard to read when it comes down to it. But yeah, this is why you want something like a Cilium or something like this, because basically what we're doing here is we're using BPF as a programming language to do some relatively interesting and complex things for traffic, like whether or not traffic is allowed to when a process makes a connect call, right? Basically, from when that process makes a connect call and opens that socket, we handle the rest from there, right? So when you're using BPF, you're actually going to be able to see. When you're using Cilium, we're using BPF to basically grab that socket connect call and then decide what to do with that from our perspective, right? So if we're using kubeproxy replacement, for example, we can determine, okay, well, this is a call to a service. This service has these healthy endpoints. We're going to make the routing decision about which one to make it to, and then modify the packet so that the destination is now that destination source IP or the destination IP of the selected endpoint behind that service. If we're not running in kubeproxy, then we let kubeproxy make that decision and we skip it. But there's a lot of programming that we do from that perspective. Now, another thing that I think you might find useful, which I personally find a little easier to grok.
You may want to clear the comment.
Oh, sorry. Yeah.
Sorry.
I'm terrible at that. So if you exec into a Cilium pod, a -n kube system, Cilium, let's jump into 2.5 here. So once you're inside of here, you can actually use the Cilium command that is inside of the node to look around a little bit more. And I think this is probably going to be a little bit more like what you were looking for, right? And so what this is going to do is give you a view of how Cilium sees the world kind of operationally. We can see things like IP mask list. We're not doing any IP mask. I don't think that's actually even enabled in this particular version of Cluster. But let's see. Maybe is there any metrics? So here are some of the metrics that are exposed. Here are the. See if we're doing any NAT. We're not. If you had This is the IP cache, so we can understand like what the IP address is back and forth between all of the nodes and everything, and have quick lookups. So like this value will probably be an identity value associated with an IP address in one of these things. So we have kind of the operational view of what's actually happening inside of the cluster. Endpoint list will show you all of the endpoints that are known about on this particular node. IP cache is more of a global thing. We can show the BPF connectivity table, the contract table. So you know how like in IP tables you have a contract table that you're actually mapping? If we do contract inside of BPF, this is actually where we host the view of that. I messed that up. Lists.
It wants an endpoint.
But here's some connections that we're actually managing inside of the contract side of things for eBPF. But there's a bunch of other stuff, even without the BPF, that might be useful to understand, right? So we can do node list. Here's all the nodes that we see from the Cilium's perspective. And if there were one missing, you'd probably kind of want to know that. But that's one way that you can find that out. If you have any FQDN policies that you've defined, which we don't currently, but if you created a network policy that said, applications in a given namespace can communicate to google.com, but in all of the other namespaces they can't, then how we actually manage that, because you're providing a fully qualified domain inside of a network policy, and we're still going to effectively be making decisions about that on an IP level, we have to have somewhere where we actually cache what the response for the DNS query for that FQDN is over time.
You got to translate the layer 7 to layer 4 and figure out.
Exactly. Right. So you still have the convenience of defining FQDN, but we also still have the underlying requirement that at some point that becomes an IP address that we are actually allowing or disallowing traffic for based on the network policy that you've defined. So that's kind of a rabbit hole you could jump down and play with and dig into and see how that works. There's also the map stuff. So I think the map stuff might be super interesting to you because it actually describes the maps that we're using to host things that are interesting to us, like L4 backends, L4 services, egresses, NATs, the metrics. All of these things are maps. And the reason, the way maps conceptually work generally in the eBPF is that they are sort of the glue that allows us to take the context that we've derived at the kernel, or that we want to provide to the kernel, say like a list of IP addresses or what have you, and then pull information off of those maps down into user space. Maybe for metrics, for example, right? Any metrics that I gather up at the kernel layer, which basically gives me all of that rich context about what's happening at the process level. I want to be able to take those metrics and then pull them down into user space so that we can then throw them into like a metrics endpoint behind a program, right? So that Prometheus can get a hold of them and that sort of stuff. But Prometheus isn't going to be able to scrape the kernel directly. So we need to have some way of actually getting that back and forth between what's happening in the kernel, where the context is derived, down to a place where it can actually be presented, like by a biometrics endpoint for the Cilium agent, for example.
Cool.
But yeah, all good things. So, so at this point, basically what I showed you was how to get from like a regular Cilium into a regular, or from the EKS Cilium to the OSS Cilium. You can also do this with the regular EKS Cilium to an enterprise Cilium if you wanted to try that one and turn on some of the other features and capabilities. But overall, like, it's a really super exciting. I think it's like super exciting that EKS Anywhere and or that Amazon and Isovalent were able to partner on this and make a great CNI choice for EKS Anywhere customers. Like that's awesome.
Oh, I mean, and you're showing all the power of Cilium, right? Like these are the things that you need in a lot of contexts on-prem. Like you can't necessarily, use the least featureful or basic sort of like routing packets on-prem is actually kind of difficult, and getting that access in the host itself. And also like you have how many layers of networking and teams of people that actually do that for you on-prem too. So being able to debug those things, being able to visualize and understand, hey, this is where that broke. Wireshark's great. TCP dump is great. I can't tell you how many problems I've solved with those things. But once you go... Once you go a layer into Kubernetes, and now you're like, okay, now I'm in a namespace that has a CNI, that now has a host, that has a NIC, that has 3 shared IPs, that like all of those things get really difficult to actually debug, and getting that kernel level observability is really important.
Yeah, exactly. Yeah, I mean, I think that's the killer part of it. You know, like I was saying, one of the things that excites me about having like a kind of a global view of traffic is like, it's similar in some ways to the way that people think about tracing and those sorts of things, right? Being able to understand the immediacy of the problem that I'm looking at on this interface is very useful information. But being able to understand how that correlates to other things happening in the cluster within that same problem domain, like within a given namespace or within a given on traffic happening between namespaces and that sort of stuff. That's where I feel like the real killer piece of this is. And then the other bit of that I think was also really kind of an eye-opener for me was in many environments, you know, talking about like decisions that you have to make as a provider. In many environments, things like PCAP are disabled. So if you're trying to debug an application that you have deployed into Kubernetes, that application is running inside of a pod that will not be able to run PCAP because that's a net admin capability that you won't be able to get inside of that running pod.
I mean,
for good reason, you know.
I guess we should say PCAP should be disabled in a lot of environments. Yeah. If it's not now, like that is something that if you don't need it, you should get rid of it because it is it is a possible security vector.
Yeah, exactly. Whereas something like this, where really what you're trying to understand is the connectivity working or not? Yeah. Show me that, right? And even within Helble, we can show like, we can turn on what we call fine-grained sensors. And we can actually even show like what the request error code was. Was it a 200? Was it a 400? Was it a 503? Like we can actually express that stuff and actually, give you more deep visibility into what's actually happening on that connectivity side. Let's go back to our audience to see how everybody's doing. So Chaco asks, does the pod that was created by the first CNI still work now, or do I have to restart the old pods? And so in this case, what will happen is because I'm modifying the underlying CNI, any existing vs that were there will probably continue to work, right? As long as the kernel programs are all reinserted and everything that, like from the Cilium, from the CNI's perspective is running, then things will continue to work. It'll just basically become aware of those endpoints and continue to work. Worst case scenario, you have to do a scenario where you like shut everything down and then the kubelet will actually become unready for a time because the CNI is no longer available, right? And then when you spin up that new CNI, when the kubelet tries to understand the health or the operation of any pods that were running on the old CNI, it will fail to do so, decide that those pods are dead, delete them, and then kind of go back through that same provisioning process that it would have run in the first CNI to bring up those things, make sure that it gets a VETH, wire it up into the system, install all the programs.
At that point, it's the same thing as any unhealthy pod, right? It's like, hey, this shouldn't exist. I'm going to delete it from me. Yeah. The controller manager then says, oh, that pod's gone. I'm going to create a new one. Hey, the scheduler picks that up, says, okay, we got to assign it to a node, and then the kubelet picks it up again. So yeah, it's the same workflow of Kubernetes coming down. It's like, hey, once something's unhealthy and deleted, let's just start that workflow again because it's immutable.
Exactly. Let's clean it up and fix it. Yep. Yeah, so I think that was all we wanted to cover today. I realize this has run a little bit over. We're at like 12:23. I wanted to thank Russell and Chaco and Carlos for asking all of your awesome questions. Thank you very much, and thank you for joining me, Justin. And I think that as we move forward, I think one of our intentions at Isovalent is actually to make it so that you have the ability to just plug like a lot of this observability in, like directly into the EKS deployment of Cilium. But you wouldn't even necessarily have to uninstall and reinstall. You just be able to like bolt this other capability on and have that as part of the supported piece. So like I know that we're working in like a variety of different areas like that just to make the Cilium experience on EKS Anywhere as best it can be and make it really available and make it awesome. So thank you very much.
Yeah, thanks for having me. It's been great.
And I'll see you all next time. I think next week is I'm not sure. I think Liz is doing another one before the break, but I'm not totally certain of that. But if we are, you'll see the notifications on our Twitter and also inside of the Cilium Slack. And if we aren't, then you'll also see that notification. So thanks a bunch, everyone. Have an awesome weekend, and I look forward to seeing as many of you virtually or in person at KubeCon and all of those events as we can. So have a great time.
Yeah. Thank you.